All right. So start to search, research, and find the information about those topic that has been allocated, or rather you were lucky to get. Okay, so I know some of you are not maybe happy with this, but there is no better way. I could not find any better way. All right. Okay, so this is actually every week, every semester we do this in the class, the lucky draw we do in the class. So student has to pick up whatever they get, they will, I mean, they pick, they will be assigned to that group of that topic. All right, so this is nothing new. This is already a practice. The good thing is, you guys, since you are in here online, so anybody can contact to others at any time, right? In real time, anytime. So there is no school time or office time for you guys. And of course, you have the other social platform to meet up. So what I'm telling you that when you are writing about your project, right? About your project, whatever topic it is, you also keep an eye open to other projects as well. All right. So when you are keeping your other project and discussing with other students, other friends, other groups with other renewable energy topic, so that you can make a good comparison with yours to them, and that is the good thing, you know. Believe me, that is the good thing, that how much you compare your one is more promising or not that promising, or how it could be more promising than other group, those who are doing. All right, so that's why if you think that you want other topic, so there is your opportunity to work on, to learn more from others by discussing. And it is not a competition, it is a performance. How much you can make it maximize your chances. That's it. All right, so is there any other question? Otherwise, I will go to our lab session today. By the way, my laptop is, I don't know, I cannot connect to this MS Teams. I do not know what happens to my laptop. Restart. Okay, if I can restart, then I will come online, I mean, with my photo, with my video. Hopefully it will be okay now. Okay, so this experiment 2, analysis of brick cleaner, if you have gone through it, you already know that it is very similar to that you have done for the experiment 1. All right, so what you have done in experiment 1, this is another way of expressing it, that brick cleaner 2, I mean analysis of brick cleaner 2. This is as well an acid and base reaction, and like other acid and base reaction, we do titration to find out what are the concentration, or how the quantity, or whatever the percentage. And here for this reaction, you already have seen the stoichiometric ratio for this reaction. And those who paid attention yesterday, it was on the lecture slide as well. Now, so what is the purpose of doing this? The thing is, okay, I'm online. It looks like I'm online. Hold on, I need to take the background. Okay. So, what I was saying, why do you need to do this? I mean, what is the real purpose, right? Real life purpose. The brick cleaner or the drain cleaner, brick cleaner is for acid, drain cleaner is for used sodium hydroxide. So this is an acid, and let's say that in your premises, in your area, some new company came out, industry came out, and they are supplying this brick cleaner. Brick cleaner is important because for construction and for our keeping our housing area, our house is clear and looks better. All right. So let's say they are coming out and they say that, okay, our brick cleaner is very good and it has X percentage of ACL in it, because ACL is not cheap, right? So ACL, so how do you just trust them, or you want to see that, okay, you want to know that I want to know how if they are okay, or if they are really, this product is good. There are two ways to know the product good. One is apply on the for your need, and if your need is fulfilled and you are satisfied, then your the product is good. Or another thing is you try and evaluate its quality, right, in the lab. By the way, if you want to apply it, you also have to have something, right, that if the product is good or not, you also have to know how to apply this thing. It's not only on the product always. Okay, so these two things, and buying it and applying is a little bit problematic, time consuming, and also it takes money, and buying and throwing it. So why don't we just do it in the lab, right? That's the best possible way, and that is what we need to try, the quality of that brick cleaner. So for this brick cleaner, the first thing comes, I mean, if I look at it, it comes to my mind that it is ACL, that's good, but it is sodium carbonate, not sodium hydroxide, right? So this is one thing. So how do we do it? How do we proceed for the brick cleaner? All those things you should need. Spatula means, I think you know already, right? Spatula is the spoon type things that we use to transfer the chemicals, solid chemicals for weighing, measuring. Okay, so all those things, it will be needed for us typically in the lab. And with this, with this thing, what we will do is we will weigh 2.5 to 2.8 gram of sodium anhydrous. Anhydrous means there is no water molecule in the sodium carbonate, right? This is sodium carbonate we are using. This is the sodium carbonate we are using, and there is no water molecule tagged with this molecule of sodium carbonate. That's why it is called anhydrous. That means there is no water, it's very dry. So anhydrous sodium carbonate is in weighing bottle or weighing tray. This is we have the weighing tray. It looks like this type of tray, and we use for weighing, and we record the exact mass. Exact mass. Can anybody tell me how many decimal places should we take for this exact mass? Anybody? 2 decimal places, right? Because here, yeah, I think somebody have replied. Yes, thank you. Yes, 2 decimal places we would take for this, but the significant figure is 3, right? After we take the 2 decimal places, the significant figure remains 3. It is still because this trailing 0 is counted, not in front. In front of the 0 will not be counted. So this is the 3 significant figure and 2 decimal places. All right. So now we take this, and after that, what do you do? We have ourselves. We trust ourselves, right? I believe that we trust ourselves. Huh? that I did it myself. Like I saw it in my eyes, right? So I do it myself. So I trust myself that I have taken 2.5 or 2.55 or 2.7 gram, right? So I trust myself. And the good thing is, this is sodium carbonate is powder, so I can actually weigh it, right? I can actually weigh it. I mean, exact to exact to 3 decimal places in our lab, in the electronic balance. It can weigh until 4 decimal places, but usually we take 3 decimal places because the last one is uncertain, right? So we took it and we know exact this amount until 2 decimal places in the sodium carbonate I have. So I have, sorry. Oh, this is okay. So I have this sodium carbonate with me, and then what we will do is I will make this sodium carbonate solution in a round bottom flask or a volumetric flask. We already have talked about what is a volumetric flask or round bottom flask. And since I know the gram I have taken, if I take let's say 2.65 gram, right? 2.65 gram of sodium carbonate. We know how many moles are there, right? We already know how many moles are there because so we know how many moles are there because we ourselves have taken it. We ourselves have taken it, and then we can just divide by the molecular weight of sodium carbonate. You can find it. And then we dilute it into 250 milliliter volumetric flask. So when it is 250 milliliter volumetric flask, this number of moles, the molecular weight of sodium carbonate is probably 90 something, forgot. Okay, so we know the number of moles in 250 milliliters. So that means we know the molarity of the solution. Already we know the molarity of the solution. Or if we need to prepare a molarity, we can find it. Anyway, I will go through actually because I am sure that you already have done it from the experiment 1. So you are already. Oh, yeah. So in the morning, I actually was telling that since you already have done it, you have the experience of doing this. Do you have any question? So that it's better not to bother you or make you boring. Then I reply. I mean, I can answer some questions if you have. All right. So the second step, we make the solution by transferring it into a round bottom flask. And then I use deionized water. In this case, this says deionized, but for our case, we would be using distilled water. Right? Distilled water means the water that evaporates and then comes back from the vapor state to cool down to water. So that is the distilled water. So that distilled water we will be using to half fill, because this is the round bottom flask, right? This is the round bottom flask. We put the sample here. We put the sample here and then put water until this part, and then we swirl it. We swirl it nicely, both round, clockwise, anti-clockwise, until all the solid get dissolved, right? And then let's say this is the mark. Up until this mark, it will be 250. Only then we add more water to fill it up to this. Do not fill it up at the very beginning and then swirl. Don't. Okay. Okay. And okay, after we fill it up to this mark, what we'll do is we will invert this round bottom flask few times like this. Invert the few times, and so that we expect the whole thing will be mixed nicely and totally. All right, so this is the preparation of a standard solution. A standard solution, why? Because we know, we created the solution. We know that what is the concentration of it, or we can change the concentration of it, or it is, we know it exactly what is the concentration of the solution. So that is why it is a standard solution. And now this is the unknown solution. We did not create this solution. We cannot control the solution. We just took it. So this is not in our hand. All right. So what we'll do is we will clean and dry a 250, another 250 milliliter round bottom flask like this flask that now just now this is the round bottom flask RB or volumetric flask. All right, round bottom flask or volumetric flask, it says. Okay, so this one, what we will do in another round bottom or volumetric flask, we will first wash it, rinse it with the distilled water, and then dry it thoroughly so that there is no more water, not even a single drop in the water. And then I will put the stopper, that means the cap, on the top so that it becomes closed. So after that, I will put it in the weighing balance, electronic balance. I will put it, I'll weigh it. If I weigh in the weighing balance, what will happen is I will get a value. After that, I note down the value, right? I'm coming to that table. Actually, this one will be table 2.1. It is not 2.2, sorry. This is a printing, typing mistake. It will be 2.1, table 2.1. So after that, I will take 5 milliliter of the brick cleaner, 5 milliliter of the brick cleaner, and transfer it to that 250 milliliter brown bottom or volumetric flask, right? And in this case, what will happen is we will transfer it very carefully, because if we lose any single small droplet, that means we are losing the number of moles of HCl that is inside this 5 milliliter brick cleaner, right? So we would not want to lose any of it. If we lose, there, of course, the result is very much different. So we will be very, very careful to transfer from this 5 milliliter to 250 milliliter. And then I will just, what do you call it, stop. Again, I put the cap on it, and then I will weigh it. Again, I will weigh it. If I weigh it, so I get from the empty round bottom flask some weight. I get this around, I mean, after I put this 5 milliliter in this, I get some weight. And what is that? I mean, the difference is the weight of what? Can anybody tell me? What is that? If we do this, what will the resulting way we find? The difference between those two is the weight of what? Anybody? Anybody? My question is not clear. Like, I get empty bottle way here, volumetric flask way here. There I get the way with 5 milliliter, right? So the difference between them is the way of what? The mass of what? Megan, thank you. Gabriel, mole per gram, product. Anyone else? Anyone else? There is no marks on it, la. Just type whatever you want to type. Jonathan, water. Anyone else? Any idea? What will be the weight by this difference? Make it a bit clear. Like, I weigh the clean, empty, clean volumetric flask, and let's say I get it is X mass, X gram. And with this 5 milliliter, I get Y gram, right? So Y minus X is equals to what? What is the mass of Y minus X? Chen Wang Kong, mass of reactant. Yes, thank you, Jonathan. And Chen Wang, yeah, you are also correct. If we, because the brick cleaner is a reactant here, so, or HCl here, so it's a reactant as well. Mass of the brick cleaner solution. Yes, Bernice, thank you so much. I was looking for this, the mass of the brick cleaner solution. All the answers are correct actually. Mass of the reactant, brick cleaner solution, mass of the, all are correct, but this is what I was looking, because it fulfills my requirement actually, so that I can talk more about it. Okay, so this is it. We get the mass of 5 milliliter brick cleaner solution. Now you have to tell me, okay, not now, later. Okay, I take this, I reweigh, and then I get the mass of 5 milliliter brick cleaner solution. So this one, and I will record it here. Mass of empty volumetric flask, that is X, and that is Y, and that is Y minus X. Y minus X, right? So hydrogen chloride content, I do not know, maybe XYZ, there's a percentage. This is a percentage. The manufacturer says a percentage. So I get X, I get Y, I get Y minus X. Okay. After that, what I will do is, now, only now, after I take the weight of this 5 milliliter solution, then I start to add water to make it up to 250 milliliter. So I took 5 milliliter, and then I am adding more water to make it 250 milliliter. Where is that? To the calibration line. Calibration line is that line that I was telling you, that here, right? This is the calibration line. So at this point, if I fill it up, it will be 250 milliliter. All right, it will be 250 milliliter. If it is here, we do not know, we cannot tell. It's 220, 210, or 200, or what, we do not know. Only one thing we know, only one result we know, that if we fill up that mark, that is 250 milliliter. Below or above, we do not know. So that's why when we pour the water in volumetric flask, we have to be very, very careful, because one single drop can change the concentration. Okay, so after that, we took 5, make it 250 milliliter, right? So no. X and Y is just for an example, okay? X and Y is just for an example. You will be given the data, actual data. Okay, so after that, we have 5 milliliter, and we make it, we took it 5 milliliter in here, and we make it 250 milliliter, right? So what can we get from here? Can anybody tell me what is happening here? I'm taking 5 milliliter here, I'm making 250 milliliter. Anybody? Megan, dilution, thank you. So do we need to define? No. All right. Okay. So Megan, dilution. Can you tell me what is the dilution factor here? Easy, right? Dilution factor. What is the dilution factor? How many times I'm diluting it? That is the dilution factor, right? If I dilute 5 to, yes, 1:50. Yes, good. So this is, if I dilute 10 to 100, that means I'm diluting 10 times. It was 10, then I make 20, so double, I make it 30, so triple, and 40, 55 times, 6 times like this, and then 200, it becomes 100%. So the good thing is, just divide 250 by 5, all right? So with that, we get the dilution factor. That is the dilution factor, that we diluting the solution to that extent. All right, so here in this round bottom flask, I have diluted solution. DIL means diluted solution. But from if I get the concentration of this diluted solution, I can easily find the concentration of 5 milliliter solution in the original, not in the diluted, but original, because we can just multiply, right, the dilution factor. All right. So this is extra thing. Now, after this, point number 6. Point number 6, what we will do is I will use a pipette. I will take a clean, dry pipette, and then I will take a little bit from here. Let's say that I'm taking a 10 milliliter pipette. I will take a little bit, 5 milliliter of that, and then I will rinse the pipette like this. I will take, fill it up, and then rinse a little bit like I will tilt the pipette in this way a little bit so that it does not go into the, the suction pump. So a little bit, and then I throw it so that I trying to make sure that it is not contaminating whatever maybe, I do not know, whatever, if there is anything, it is not contaminating. Everything is this brick cleaner solution. So I will take it and then I rinse the pipette, and then I take 20 milliliter from here. 20 milliliter, I take it from here, okay, from this solution, and then I put it in what do you call it? Oh, sorry. All right. Sorry. That is. Now for the number 6. Number 6, we go back to this standard solution. I take that one, the solution that I prepared here, right? The solution I prepared here, I take 20 milliliter from here. Of course, we rinse the pipette also and take 20 milliliter from here and take it in a, what do you call it, here. Take it in a beaker, not beaker, that is called Erlenmeyer flask or conical flask. Okay, so 20 milliliter I took it. 20 milliliter I took it of sodium carbonate, Na2CO3. Okay, Na2CO3, we took it here, 20 milliliter. After that, let's say 20 milliliter is this part, it is this here, and then what I'll do is I put few drops of methyl orange, right? I put few drops, like 2 drops of methyl orange, and on it there will be a burette. So in that burette, I will put this HCl solution or brick cleaner, the brick cleaner BC. Okay, the brick cleaner is coming from the top, that is the tighter it becomes. Okay, and we have to record, like, this is the initial IN, and how many milliliter of this brick cleaner I need to add from this burette. It will be the final. It will be the final result, initial, and this will be the final result. So let's say initial I start like 4 milliliter. You already know that, I don't need to talk, but it's 4 milliliter if anybody has any inquiry. And then the final is 29 milliliter, right? So how do I know that how many milliliter I took it? I need it. I just subtract this initial minus this final. So subtract that initial, that means 4 milliliter minus 29 milliliter, it will be 25. It will be 25 milliliter. So that is how we will find the volume of the titer. So come here now. Volume of the volumetric flask used, let's say that 250 milliliter, you took a actual mass of anhydrous solution. So that will be given to you of how much you have taken. I do not know yet. I will give it by tomorrow, by this evening. Hopefully that everything goes fine then. Okay, so after this, this is the final, initial and final. This is the initial. This is the final one, that is 29, let's say, and I have 4. I have 4. So you know that. I mean here. All right. Now come to the calculation. How much, based on the actual mass of sodium carbonate used, calculate the concentration in moles per liter, all right, of sodium carbonate solution. How can we do that? Of course we can do that, because the sodium carbonate we have taken ourselves. So we know how many moles are there, right? In 2.7, 2.5, 2.6, whatever gram we have taken, we know the number of moles in there. And then in each mole, calculate the amount of sodium carbonate in mole present in each conical flask. So we have taken 20 milliliter of sodium carbonate in this conical. For this, for this, for this, for everyone, we have taken 20 milliliter. Okay, so we can just show one conical flask calculation, then it will be fine. So in 20 milliliter, how many moles? Remember that although we know 2.5 we have taken, so from there it was diluted 250 milliliter. So in 250 milliliter, how many moles? In 20 milliliter, how many moles will be there? Please show in the steps, okay, calculation. From there, if we know that in 20 milliliter in the conical flask, I had, let's say, alpha number of moles, we can easily find how many moles of HCl will be, because this is 1:2 reaction, right? 1:2 reaction. If 1 mole of alpha, I would need 2 moles of HCl. So I know from there that what is the number of moles of HCl. Okay, and then we need to calculate the amount of hydrochloric acid in moles present in volumetric flask. So from there, we can find the number of moles. Is the same, almost similar thing, right? We can find it very easily. Find the percent by mass of HCl in the brick cleaner. Now there is a question I'm going to ask you. If we know the number of moles, let's say this is beta. This is beta we get. We know the number of moles of brick cleaner in how many moles? Let's say 25 milliliter it was needed. 25 milliliter it was needed, right, to titrate this 20 milliliter. Just for example. So in 25 milliliter, beta moles of HCl are there. Then what will be in 250 milliliter, right? And then from there, remember the dilution factor, what will be in 5 milliliter, right? So what will be in 5 milliliter? And from there, we need to have this percentage mass, weight by weight percentage, weight by weight percentage, right? So it's W weight by weight percentage, we take it. How do we find the weight of HCl or brick cleaner, actually, brick cleaner? Because oh, sorry, the brick cleaner weight we can, I mean, HCl weight we can just find the number of moles, right? The number of moles we just multiply with the molecular weight so that we can find the gram of HCl, how many gram of HCl is there. But it was in 5 milliliter. How do we find the gram of 5 milliliter? How can I convert the gram of 5 milliliter? Anybody? Anybody? Hello, can you hear me? So quiet. How do you find the mass of 5 milliliter brick cleaner? Because the brick cleaner came in liquid form. I am asking you to find the mass of brick cleaner of 5 milliliter. How do you find it? Hello. What we will do is that since we already know what is the mass of this, right? Let's say it is a Z. This is the mass. We need to have we have to use the density of 5 milliliter. What is if we multiply by density, we will get the mass, right? So what will happen is, how do we get the density? Because the Z is here, all right? So this is mass and the volume is 5 milliliter. So mass over volume, this is the, from here we will find, oh no, sorry, what I'm doing, don't be confused. This is the mass. So if we divide by 5, the volume, 5 milliliter volume, so we will get mass over volume, gram per milliliter. So that will be the density. That will be the density of that. So from here we can get the density of the brick cleaner sample. All right. So if I don't even give you the density, don't bother, don't be panicked. Okay. Afterwards, you go for the discussion and conclusion. What we will do in the discussion is summarize the result. Summarize means do not just write whatever you got the result already. You tell in your word that, for an example, if in the result the concentration was found as similar proportion, okay, or as expected, or the concentration was found, or number of moles was of the reactant was found as per the stoichiometric coefficient, stoichiometric ratio, or you can say that the mass was the known mass was known for it, gram per molar, number of moles was known as it. So it goes smoothly. Or you can say that I'm giving you too many hints. Okay, so you can say that the number of moles was this, was X or alpha or beta, and it is in proportion to the chemical equation shown. Okay, so these things you can write in this way in your word, okay, rather than just alpha and okay, whatever the number of moles or number of moles of that. So comment on the accuracy of the manufacturer's claim. What could have been the problem that it is not accurate, or why? Who is in fault, you or the manufacturer, right? For your exam, information, if you want to say the manufacturer is wrong, then you have to have a very strong reason to say that manufacturer is wrong, right? Okay, so, or sometimes we need to consider the error as well, the random error, and what is that called? That what is another error? I forgot. Yesterday we were discussing about it. So this type of two error thing can happen. So if this type of error happens, then the result or the reading is very much different. And how could you minimize those errors? You can also talk about it. And if your result is very accurate, justify that what you have done correctly to ensure the accuracy of the result. Procedure, highlight some of the evidence from your data. That means if your result is very good, very near to the manufacturer's claim, within plus minus 5%, so that what precautions you have taken. I know that you are not doing the lab, but you can say that, let's say that who, let's say that one student Mr. X, okay? So Mr. X, or sorry, just X, Mr. or Miss X. So what he or she has done accurately, that the result is so good, or why should he or she be praised? How good she has done this thing. So these are the things you can write in this discussion. And before I finish, I would just want to inform you that experiment 2 and experiment 3, okay, 2 and 3. Experiment 2 and 3 are group wise. That means unlike experiment 1 where all of you have submitted, here you will put your heads together, you will sit together, or you will discuss together, all right? You discuss together and then you come up with a group wise, like not everyone has to submit, you submit for your group, all right? For your group you submit, all right? And everyone has to work in the group. So you can choose that you want to, you can choose, all of you can, what do you call it, contribute in every, that like data analysis, calculation, and the discussion, result and discussion. Or you can say that, okay, we distribute, or we divide the task among us and we will do this part. This is because that all of you have already experienced some difficulties, some hurdle during the submission of first experiment. That was deliberate actually, so that when you face the problem, you know more about the problem. Maybe you don't know the solution, but you know the problem. So that's why I'm asking that if you have any question, you can ask, or you can share with your friends what the problem they faced, and then how they can you guys sit together and discuss how you can come over it and overcome it, right? So this is the reason that I want to make it this, and another reason is it is very similar to the titration is very similar, so there is no point of burdening you guys. So that's why I'm saying that it should be group project, okay? So one per group, anyone you choose that I want to submit, okay? So other two members have not have to submit that, or anybody from group can submit. Write all of your group members' name on the first page, all right? Write all of your group members' name on the first page. Here, write 1, 2, 3. Group 1 or group 2 or group 3, whatever you write, right? So 1, 2, 3, this is the number of group members. Write your name here, write your group member's name, another group member's name. And student ID, you write also the same, 1, 2, 3. 2, 3 as well. Date no need to write, and group number need to be written. Please write the group number. Okay, this is needed, this is needed, and of course this is needed as well. Okay, so so many questions. My God. Find the moles first. Bernice, find the moles first. I think I missed this question. You had better to just at that time when I was talking to speak up. I don't understand the question. If you still haven't found the answer, please talk. Jonathan, should we do discussion in paragraph or point form is okay? Both are okay. Both are okay. So you can do in paragraph, or if you can do in point as well, but not all the things in point. At least give some in the paragraph, because if you write the paragraph, that is the most professional way. But it is good to have some points. It's good to have some points, okay, in this discussion. So Megan sir, is okay to write the conclusion in point form, or it is better to write in this sentence? Okay, yeah, it is okay to write, give some points, and then at the end, maybe 1 or 2 sentences. So group experiment 2 is for the first true group work. Yep, Brandon, yes, this is the first true group work. Ultimate Zincs, I do not understand what does it mean. So only one person need to upload the whole for the whole, yes, only one need to upload for the whole group. So is there any specific point that we need to explain for the summary of the conclusion? Good question, I missed it. I wanted to say but I forgot. Conclusion for not only this lab report, for any report you write from now on, whatever you write, I mean, if you go for the professional life, the conclusion should always refer to the aim of the project. Our aim or purpose for this project is this, right? So your conclusion will refer to here that whether you have achieved this conclusion, the aim or objective, how good have you achieved it, right? And what could have been better, but in a very small, very like 2-3 in discussion you write discuss in lengthy form. In conclusion, this is the key thing, that whether this aim has been achieved, okay, how good the aim has been achieved, how could it be more better. So those 2-3 things can be in the conclusion. I hope this answer your question, Bernice. So only one person need to upload? No, only one person need to upload for the whole group. Okay, wait, I'm coming there. Mergen. So if I am not wrong, the last lab report was individual submission, but from now on all lab report will be submitted as per our lab group, one submission from each group. No, Marjan, don't, I mean, okay, so the thing I'm telling, only second and third. So this one, the current one, lab report, this brick cleaner, and the next one, I forgot what is the next one. So these two be only be group work. Okay, right now I know. I do not know, maybe I will make, we have 9 labs, maybe I will make other labs as group as well, but not now, all right? So these two be only group. If there are more group work, then I will tell you, of course. That's why if you go to that announcement section, I announced about the assessment and clearer. So there I said in the bracket, until further notice. Okay, so if I do not notice, I do not tell you, I do not say it, or I don't announce it, please don't think that it is okay already. Or if you have doubt, then you can just email me whether it's a group or not. But I will, of course, during the discussion, I will tell. This group is different from the project group, right? Yes. Have you seen that in the Canvas that you are already under the some group project, I mean lab group? Have you seen that? I hope that you have seen, or go, and if not, then please go and check. Okay, chemistry has 2 groups, one for a lab report and another for group assignment. Yes, thank you, Marjan, for the clarification. And if you want me to set a group leader from each group who will upload on behalf of you, then I can do it. You want me to do that? Is it better that I set someone as a group leader, so he or she will have to upload it? Vote please, vote please. I got only one yes. I need at least how many here? How many here? Almost 36. I need at least 20, 24 like that, so that I will say okay. Yes, 2, 3. Yeah, just one. A group leaders can be only one, right? How many leaders do you want in a group? If too many leaders, then there will be fight. I'm not joking. Yes. Why are you abstain? Why do you abstain? Okay, let me count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not sure yet. Okay, 10, 10, 10, 10. Oof, I need more votes. Only then I will do it. If not, then you have to discuss and with among you, and then you will need to find who will upload it for you. Okay. Okay, so this is one thing. Another thing I wanted to tell about. Okay, so any other question? Anybody has any other question? Any question? Since we have time, it's not 3 yet. Any question? You want to just chit chat? I'm okay. Oh my God, I forgot to roll call. I forgot to roll call. Okay. I see. Please say. No, hold on. Anybody can say. No, I cannot from here. Okay. Please say yes if you are here. Muhammad Anis. Siang with you. No. Carlo. I think I saw.
I'm here, sir.
Okay. Nishi Mitra. No. Rizvi Rizwan.
Yes, sir.
Hao Liang Sun.
Yes, sir.
Gwenda.
Yes.
Tammy.
Here.
Yu Chen Chong.
Here.
Thank you. Kelvin.
Here.
Ntimisha. Ntambu.
Here.
Okay. You were not here yesterday, and have you submitted your lab report 1?
Not yet.
Why?
I didn't
Okay.
know it was due Monday.
Come on.
My
How
bad.
many times? How many times? I mean, at least check the canvas. Okay, one thing I tell you, okay? This is a secret thing that you see. I do not know whether, okay, I'll show you one thing. But before that, okay, I'll show you one thing. Then you will be a bit more serious then, I hope. Okay, so this is it, and this goes to the grade. I'm going to the grade. You see, it is already here. Oh my God, my battery. All right, it's already here. Experiment 1, experiment 2, experiment 3, experiment. If everything is nicely arranged, so if you are not submitting, here, I cannot do anything. It will be automatically 0. Right? It will be automatically 0. if even you, I mean, I try to do that, I cannot do that. It is the system, right? So that's what I'm saying, that submit, at least submit. Okay, so, all right. So now, Eman.
Here.
Good. Sophia.
Here.
Marjan, yeah, just not talk. Varun. Oh, Varun was here in the morning. Gia Keki.
Yes.
Bernice, yes. Chen Liang Tia.
Yeah.
Good. Megan, yes.
Yes.
Yeah, because I'm saying yes because I remember that I was replying their messages. Jia Wei Sun.
Here.
Angel.
Yes.
Darren Pan.
Yeah.
Then Brendan Sim.
Yeah.
Adelaide.
Here.
Sagar Shankar Roy.
Here.
Lian Sun T.
Here.
Brian Kong. Brian
Yes, sir.
Kong. Okay. Darren John.
Yeah.
Okay. Lik Seng Tan.
Here.
Jonathan.
Yes.
Gabriel.
Yes, sir.
Tanya Radzwa.
Yes, sir.
I think you also haven't submitted. Let me check. What I remember.
I did submit it yesterday.
Okay, hold on. Have you submitted the safety also?
Yes, I did.
Oh, yeah. Sorry. My bad. Sorry.
It's all right.
Okay. So, Chuin Chet Sim.
Yes, sir.
Che Wen Kong. Che Wen Kong.
Sir, I'm here.
Okay, thank you. And yeah, Genuine Bandhan, yes, you are here as well, so it's good. So Nishi Mitra is not here. Xiang Wei Tio is not here. Muhammad Anis is not here as well. Okay. So I was going to ask you that if you have anything, any question, anything. Hey, Xiang Wei Tio, why don't you talk? Okay. And Nishi Mitra, are you here? Wait. It's too many. I'm losing the questions. Experiment 1 was group work. Yes. Sagar, you are here. Okay. Theo Wengshio, yes. Okay. Nishi, are you here? No. Okay. Question is okay. Rizvi, question experiment was group. No, it's okay. You submitted it. I saw it. It's good. It is individual submission. All right. So the thing is, Gwenda discuss with group member but submit individually. Gwenda, for experiment 2 and experiment 3, submit as a group, okay, not individual. 3 of you in the group, right? Every group has 3 persons. So only one person will submit on behalf of you, but you have to work. All right? You have to have the contribution in that group report. You can do the discussion or you can sit together and help to do the calculation. I don't know how you will do, but you have to do that. I'm here. Thanks, sir. Oh, there was a question in the chat. What question, Bernice? I don't know what is the question. What question are you referring to? Brandon, when is the deadline? The deadline is next Monday. Okay. Always the deadline for the lab submission is just before the next lab. Right? Just before the next lab, there will be a lab submission. And if you're not sure when is the deadline, please go and check on the submission link. The submission link is open already for experiment 2 there, and you will see that there is showing the deadline is, let me check. The deadline should be, today is 21. The deadline should be 21. Bernice, Jonathan got mentioned a question. Jonathan, I would like to know how can I highlight evidence from the data, the conclusion part. Again, highlight the evidence from the data. Okay, if I didn't get, I mean, if I got it correct, the evidence from your data in the conclusion, are you talking about, if you are talking in conclusion or in the discussion? Then in the discussion, you point out that this data was the difference between them is 0.1. Okay, the difference between them was 0.1. Between the reading was 0.1 or less. So this confirms that your data was taken much sincerely, or not sincerely, but the integrity of the data is very good. That the concordancy of the data is very good. Or the percentage, like between two results, you are getting a very low percentage of error. That means your data or your calculation is good. That is also one evidence to strengthen your argument. Okay. I hope it is clear, Jonathan. Does it answer your question? Raise B. How much marks in the conclusion part? Please refer to that marking scheme at the beginning, right? At the first page, there is a marking scheme. So what marks you get. Sir, can we send you a draft of the assignment for you to check whether the points are there for the lab report? No, my God. I'm okay to discuss. If you are unsure of anything, you can just ask me, but I cannot check before, I mean, I will check after you submit. There showed that highlight supporting evidence from your data. That's the thing, that how good, how concordant your result is. Okay, or what is the variation between the readings that you are taking. Okay, what is the variation that you need. And this thing actually will be much handy, or is much easier when we are doing lab in the lab. When we are doing it is in our hand. So that, and when I'm giving you the data, you don't have much option, right? Okay, another question is, if I submit lab 1 today, is it 10% off or can't submit at all? Yeah, it will be, if today, then 10% off. You will get 10% deduction. Might reduce. No, Gabriel. What 5-day over? Yesterday was the due date. Don't scare him. Okay. Sir, will you share the answer for experiment 1's conclusion? No, it's okay. I know you joke. I'm talking to Gabriel. But for Megan, will you share the answer for experiment 1's conclusion? Since everyone has different data, right? Although you have the same aim, but what I can tell you, there is no certain answer for experiment. What do you call it? For experiment 1 or experiment 2, 3, there is no certain answer for this. Okay, so what I can tell you about, let me check, I show you. So for experiment 1 here, to determine the concentration of ethanoic acid, right? It was, our aim was to determine the concentration of ethanoic acid, active ingredient in commercial vinegar and acid-base titration. So what will be the conclusion here, that the ethanoic acid percentage was found to be this, which is in accordance of the manufacturer's specification, like 6%, 8%, whatever, right? And in the next line, it would be okay to write that this, although it is 8%, 8% and 10% is not very, 5%, 10%, 6% is not very high. Although it is a low percentage, but this method of doing this titration is helping, or is good to find out the concentration of unknown ingredients in the acid. So that will be one point to make in the conclusion. Another point, if it were not there, it could mean that errors, we need to be careful about the errors. The error need to be checked. Whether the what error happened, every step we have to find out what error, or do the repetition, do the repeat the trials to reduce the random error, right? So that would be one thing to write in the conclusion. Conclusion is, you conclude. How do you conclude the thing? Okay. Is there any other question? Anyone has any other question? So you have to set up, set together, and then work together, initiate. Don't wait for your group member to initiate. I'm telling to everyone, don't wait for your group member to initiate the discussion. You initiate it, okay? You initiate it. You just type a message to your group member that, hey, what time you're free, we can talk, all right? Or text them what time it's okay for them to come online and have a discussion, what you can write, or you can share that I'm thinking about this, how to be like this, or can you help me checking this? Or, I don't know how you would get together or how you would contribute in the group work, but you have to. You have to. So once again, everyone is here. I think I told 4 of us in the morning. Yes, 35 of us is here and 4 was in the morning. So all of us hold on. All of us know that this is a group work, not an individual submission. Chun Hui Chan, are you here? Yes, yes. Hello, Chun Hui Chan.
Yes, I'm here.
Okay, thank you. So, Jun Hui Chung. Okay, so I will talk to you maybe through, I mean, I will discuss with you or maybe through that email, right? Or if you want to talk to me directly, then you just wait after the session finished. Okay, so anyone has any other issues to bring up, to know, to ask, to gossip, to chit chat, anything? I'm okay, I have time today.